All right, so our next step is to connect it to the real production data. So what I want to do is connect for the filler and the copper, create a new counter and create a new state signal that will tell me what the state the machine is in. To do that, I will jump to settings and open signals and properties here. I will find my demo line that I just created and open filler machine here. Let's start from that. Let's jump to advanced and open the signals tab here. You can see the list of signals is now empty, meaning that this machine is not getting any real production data. But what we would like to do now is add a new signal. First, I will need to provide a name for that signal. So this will be my counter. The description will be the human readable description, which can be changed later. The name needs to stay the same because this is where the data will be, how the data will be remembered. Type of the signal is a very important thing here because this will determine what is the meaning behind this signal. And when creating new signals, I will need to decide whether this signal has some understandable meaning for the system or not. There are different options that I can put here. So let's explore them. If I jump to our knowledge base, you can find it also by clicking on this question mark button here. And what I will do is I will look for working with signals and rules. This is a document that will describe the how to use those signals. You can read everything from the top if you want, but I will quickly jump to the section which will explain to me what are the different types of signals that I just want to create. The first one is just a signal, nothing fancy, no meaning at all. It will just be registered. It can be viewed in the signals. It can be used in the rules later, but it has no special meaning. No processing is just a maintenance type, you can say, which will just ignore any value that is coming to the signal. It's useful if you are not sure whether you should track this value or not. Counter, this will be one of the main and most important types of signals, because if I say that this signal is a counter, it will determine what is the unit of that machine, and it will start registering, expecting that every new value is a new value for the counter for the good production of that machine. And similarly, the waste counter is the opposite. It's the waste counter for that machine. It can be also defining a different unit than the primary counter, but it is important in terms of tracking the production. Short performance is a special signal that will let us automatically track changing performance of the machine based on the counter and waste counter signals that are coming in. We'll cover that later. Energy, active counter, and energy current power are the signals which will be responsible for energy tracking for that machine. So similarly to the counters, when I select this type of signal, the system will assume this is actually an energy counter and will start to aggregating the energy, showing it in the reports. So those two are very important also in terms of what is the meaning of those of this signal. Keep alive, this is a system state. There will be just one keep alive for each machine. And you don't really need to care about that because most of the time keep alives are just configured in the implementation phase when we configure logic gates. Alright, so let's jump back. I've closed this, so let's create it again. Counter. So the type of that will be also counter. You can see it's highlighting it here. Value of that will be a decimal. Now the source URI. This is a field which I need to use to map a real physical OPC tag, which will be registered on my shop floor for the system to map it to this specific signal. So for me, it can be just signal counter. Let's create that. Device ID is like a namespace for those OPC tags, because we may have multiple OPC servers in even responsible for a single machine. That's why I can limit the scope of the source URI by using that. Most of the time you don't need to care about that, you can ignore it. Now the unit. This will be a unit of my counter. We'll cover unit in a separate video, but for now let's just assume this will be in bottles because it's a filler. I can also describe here what is the minimum and maximum expected value. It doesn't make much sense for the counter, so I will just ignore it. And finally, I will enable whether I should archive the signal, meaning that I will be able to then investigate what were the historical value and see that in the signals section. Okay, let's save that. Okay, so we have one signal which now is being tracked by this machine. Now, if we get any of this OPC tag in the system, we'll just update the value of this signal. If I jump back to monitoring and scroll down to the demo line, you will see that nothing has changed actually. Oh, actually, the small thing. We can see now that the system understands that this machine has a counter now, so it can measure what was the amount produced and what is the current performance of that machine. This is now 0 and the machine is still disconnected, same as the line, because we've so far received no value for that signal. I can go back to signals, open the filler, and I can continue doing that to configure all of my signals that I want to track for that machine. I can do then exactly the same for the copper. In this video, we've learned what the signals are and how to configure them, what are the different meanings of signal types, how can they be understood by the system. In the next video, we'll try to plug real data in that signal and see how we can use basic algorithms and our custom rules to take advantage of that data.